Hi, my name is Anirudh.
Hi, my name is Jake.
And so this is, here we're going to explain a little bit more about the robotics that have to do with our Reza project. So here we have a servo over here. So the way this is going to work is that this is a frame of our seal. So as you can see, it forms the shape of our seal. So this tail part is what we have built right now. So what this is a servo that, if you can see, we can move around as shown. So what we're gonna do is that we are going to attach the flippers to the servo. So we're gonna cut up the seal, put this inside the seal, obviously, and we're gonna connect the servo to the two tails, so that when we move the servo clockwise like this, the strings will contract, and then when we move it back, the strings will go back, so that we create movement in the flippers.
What this will allow us to do is that later on we'll be able to go ahead and connect the servos to be able to have people interact with the stuffed animal itself. So just by touching it, it'll be able to talk to you and possibly move around and go ahead and allow people to feel that it is more of a living and interacting thing than just a stuffed animal. The reason we named this Reza is that it stands for Robotic Emotional Support Animal. Our main idea being that this model will be able to help people with emotional problems that they serve. What we're hoping to accomplish with this is to give elderly people a companion that they can emotionally form an attachment with.
There are also many units in the robot, such as motors and sensors, so that it'll like detect light and touch. So eventually, what we're basically trying to get to is for a like a seal that really acts like a living pet. So, for example, in the future, we'll have touch sensors and more sophisticated robotics. So, for example, if I was to touch it, it would react. So, if I was to touch the flippers, it would move as according to touch. So, we would do that with touch sensors, and yeah.
We're basing this idea off of the Japanese seal that was already created. The only problem with that is that their cost is $5,000, while ours would be more closer to $500. What we're really hoping to achieve with this, in other words, is a much lower price for the average person to be able to have an ability to achieve one of these.
So we hope that you consider our project for future development, and we hope to be able to pitch it to you. To show a more in-depth view of how the servo works. So here we have our servo right here, and I'm going to just show how it moves right now. So here you can see it. It can move clockwise and anti-clockwise. So the main reason we have that kind of motion and how we're going to utilize that, so as we talked before about how we're going to utilize it with the tail parts. So here we have our seal, and you can imagine that this is our frame, right? So we're going to have this to be around in the middle over there inside, and then we're going to attach a string on either side of it, so that way once these strings are attached to it, when it can either contract when we turn it on either clockwise, and then it can be let go again when we turn it the other way, so that we get this clockwise anti-clockwise movement, which will coincide with a retraction and a withdrawal of the flippers in the seal. So in the actual robot, we will obviously be using code, and this won't be done manually. So instead, we'll have our goal obviously is to get some touch sensors involved, so that once the robot feels a pressure at some point, so say like there's a touch sensor here, and we'll wire it up so that when it feels a pressure and the touch sensor contracts, it'll allow for the steel to either contract or retract depending on how we code it. And obviously this part will also be inside the seal, and that's one of the reasons we chose the seal, so it has a big enough belly for us to put things inside it. So yeah.